We're going to start with the configuration into the next. First, we're going to enable FAT-FS, and in this case, this use LFN. We're going to put this on enable with a static working buffer on the DSS. Then in this parameter, we're going to select the maximum value. In this case is 4096. Then we're going to select STI1, and we're going to select full duplex master mode. In this case, we want the baud rate. It will be 10 megabytes per second. So we're going to select prescaler in H. Also, we're going to select user 2 for the serial communication with the computer in mode asynchronous, and the rest of the parameters we're going to set in default. Also, we're going to select ADC2, channel 1 and channel 2. In the parameters, we're going to select resolution ADC 80p resolution, and the clock prescaler will be synchronous clock mode divided by 4. And in the both channel, we're going to select sampling time at 645. Also, we're going to select RTC, and we're going to active clock search and calendar. In this case, our format will be in 24-hour format and data format and binary data format. Also, we're going to select this pin like an output for the chip selector. And that's it for the configuration. Then we're going to generate code and pass to K. In K, we paste these both libraries, and we add this on the application user. In this file, in user diskio.zip, we're going to modify the functions in all the files according to these things. So, for example, in user read, we're going to paste this here, and we're going to return it with these parameters. These parameters are defined here with the SD disk read, and we're going to do this for all. For example, here use write, and for use EOTL, and for use user status with these parameters. In this file, we're going to add these these things, we're going to define these variables like as int, and this one fad fs cnt and timer 1 and timer 2, and then we're going to add this function. This function is called like by sdtimer handler, and we're going to say if timer 1 is bigger than 0, so the timer 1 is going to decrement, and the same thing for the timer 2. Also, we're going to add this part. We're going to say that the variable after define, it's going to increment, and if this function here is bigger or equal than 10, so this variable it's going to equal 0, and we're going to call the function. In this file fadfsc.c, we're going to make sure that the shift selector and SPI1 it's declared here and are the same as those we previously configured in Unix. In the main code, we declare some variables and functions necessary for communication and for the conversion. Then we're going to set the time and the date, and we will create some vectors of type char to concatenate the variables. With the strprintf function, the values of the time and date will be saved as characters. These instructions will show the successful connection of the SD and the storage space of the card. We start the conversation, get the time and the date, clean the buffer, and clean the data. Then we're going to concatenate all the information. Then we're going to create a text file, and we're going to store the data on the card with this function, and that's it. Then we're going to compile the build the code and download in the target. We're going to reset the target and open Teraterm to see the serial communication. As you can see, the micro SD was mounted successfully, and the time and conversion are working fine. As you can see, when I move the potentiometers, you can see a change in the conversion ADC. Let's see if the information was successfully saved on the microSD. Now we check that all data was stored correctly.